Hey guys, this is a video for our pH scale simulation. So if you have this, we're just going to go ahead and pull up the pHet scale simulation found on this link. So what we'll do is, I have it already pulled up, so I'm just going to go ahead and do it side by side. And what we'll do, we have this table here on our notability side. We're just going to run through drain, cleaner together. Okay, and basically how you do this is how you're going to do all of them. So we go ahead to macro on our pH scale, and we can see a few different things. So one, if we click on the top with the arrow, we can see a bunch of different solutions. Those coordinate with the solutions on the handout. So we'll start with drain cleaner, and it always puts in half a liter of the solution, which in this case is drain cleaner. On the bottom left of the simulation, we have this green cursor, and this is our pH reader. It's going to tell us, if we just put it in the solution, we can get our pH. So we're not going to add any water for this table. We're just going to go ahead and record what we see. So for the first one, for drain cleaner, we have a pH of 13. 13.00. Is that acidic, basic, or neutral? We can see, we should know this, that 13 is basic. Color of solution, that would be yellow. And then if diluted, does pH increase or decrease? So for this, we do need to add water. So if we go to our simulation, on the right hand side, we have that faucet. Let's go ahead and move that blue knob. We add some water. And we can kind of see what happens as we add more water. The solution, it goes to 12.59, right? And it's continually decreasing. Right, that number is getting lower. So as we add water, we are decreasing the pH. If volume is increased, does pH increase or decrease? So volume is how much solution we have in our beaker. If we add more, really depends, but if we add more water, we're decreasing it. If we add more of the solution, we would increase it. So for these purposes, we're going to assume it's talking about water, and that would be decreasing. All right, so you're going to go ahead and do this for all of them, measuring the pH, finding the pH, and the color of solution. Next, it tells you to choose a solution, it could be any of them, and place 0.25 of the solution in the beaker and 0.25 of water in it. You should have 1 liter of solution in the beaker. Okay, so what we're going to do, we have this pipette with the solution. We're going to go until 0.25. We have to go to 0.75. All right, because we started at 0.5. And then we have to put 0.25 liters of water in it. There you go. So from that, we can find the hydronium ion concentration, hydroxide concentration, and water concentration. So I think for this, we'll need to go, let's see if I can go full screen. All right. So, for this, we need to go to our micro example. So let's go back to notability. All right, so we're at macro, we go to micro. So let's start that over. We have our, let's use hand soap. We go 0.25 of hand soap. And 0.25 of water. Oops, too much. All right, so now we can get our concentrations. Okay, so for hydronium is H3O. It's a very strong acid because it has one too many acids than a water molecule does. So for concentration, that's going to be that number we see in red in the middle of the beaker. We can see we have two numbers, right? We have the 1.4 times 10 to the negative 10, and we have the 8.41 times 10 to the 13 inside the beaker. We're going to be taking the numbers of the one inside the beaker. So we're going to say 8.41 times 10 to the 13. And we got to make sure we use our units. So that's how many ions we have in the solution. Hydroxide is our OH. So that's going to be our dark blue number, OH minus. And if we look, we'll see we have, again, look at the one in the beaker. We have 4.35 times 10 to the 19 OH ions. And then what is its water concentration? That's our normal or just blue concentration. So that's 3.33 times 10 to the 25. All right, so don't use these numbers for yours. Pick something other than hand soap. And then number 5 is looking specifically at blood. All right, so that was the video for our pHet simulation, our first pHet simulation, and I will talk to you guys later.